Hello students. So today we're going to discuss about the ray propagation in the fiber, and also we will going to find out the angle of acceptance and the numerical aperture. Now let us define the angle of acceptance. So what is the angle of acceptance or acceptance angle? So acceptance angle, it is nothing but it is the maximum angle to the fiber axis at which the light ray may enter the fiber axis in order to get propagated. So we have to understand that it is the maximum angle. So that maximum angle of the fiber axis, so that the light ray will undergo total internal reflection in the fiber. Okay. Then what is numerical aperture? So numerical aperture is the light gathering capability of an optical fiber. So it is nothing but what is the amount of light which is propagating through the optical fiber is known as numerical aperture. Now let us understand these two concepts. Let us take an optical fiber. We know that optical fiber consists of two layers. The one is the inner part, and which is called as core, and whose refractive index is N1. And the core surrounded by the layer, and it is called as cladding, and whose refractive index is N2. So always we have to keep it in a mind that to get a total internal reflection, the refractive index of the two mediums, that is a core and a cladding, is very important. So always the refractive index of a core should be greater than cladding. So the refractive index of a core must be greater than cladding to achieve total internal reflection. Now, so after considering the optical fiber, now let us incident a ray of light. So we are incidenting a ray of light from air medium. So there is a air medium at a surrounding. So whose refractive index is N0. Okay. So let me incident a ray of light AO. So ray of light, it is incidenting at an angle theta naught with respect to the fiber axis. Then what will happen when a ray is incident from air medium to the core medium? What will happen? So the ray of light get refracted. So the refracted light ray we call as OB. So the OB is the refracted ray with respect to the incident ray AO. Okay, so the angle of incidence is theta naught and the angle of refraction is theta 1. So the refracted ray, it falls at the boundary between the two mediums, that is a core and a cladding. Okay, at B. Then, so what we have to understand here, so after that the ray of light get should reflected back into the same medium to achieve the total internal reflection. So, what is the condition here to get the total internal reflection? One is the refractive index and also the second one is a critical angle. So, whenever incident a ray of light, okay, which is less than the acceptance angle, this is less than the incident angle. So, the ray of light get into the optical fiber core and get reflected back into the same medium. So we'll undergo total internal reflection like this. Okay. Another one is when we incident a ray of light which is greater than the incident angle here. Okay. So when we incident at a greater angle, so what will happen? The ray of light will get directly pass into the optical fiber cladding because the angle of incident which is greater than this acceptance angle. So this is the maximum angle. So with this angle only the ray of light will undergo total internal reflection. Beyond this, any ray which incident, so that ray will not undergo total internal reflection. It will directly get into the cladding and it will loses its strength within a short period of a time. Okay, so we have to keep it in a mind that the ray of light should incident within this acceptance angle. So whenever you incident a ray of light, so within this acceptance cone, so this is the maximum angle, okay, within this angle on both the sides, if you take a compass and if you rotate with respect to the optical fiber axis, it forms a cone shape. So within that cone shape, if you incident any ray of light, so it will get funneled and it passes through the optical fiber and it will undergo total internal reflection so that it doesn't lose any intensity while it is propagating through the optical fiber. So this we can understand that. So one is the acceptance angle. So the acceptance angle is, this is the maximum angle. So within this angle, so any ray which enters into the optical fiber will undergo total internal reflection. Okay. And numerical aperture is the, what is the amount of a light which is propagating through the optical fiber. So that is called a numerical aperture. So let us derive an expression for acceptance angle and a numerical aperture. Okay. So